We've been discussing the properties of individual particles, but in lab, we typically don't measure the properties of a single particle. We measure things like pressure, volume, temperature, and number of moles, which are all connected to large amounts of particles, or bulk systems. So let's look at how we connect the properties of individual particles to macroscopic measurements. We've already discussed the case of the internal energy, which is the sum of the energy of each particle in the system. The internal energy is a bulk macroscopic property that tells us about the energy of a large collection of particles, and each energy that we sum up is a property associated with a single molecule. So this connects the macroscopic bulk property to the microscopic property of single particles. When our bulk properties are connected to the microscopic single particle properties by a sum, we say that these variables are extensive. You'll remember this term from freshman chemistry as meaning that the property depends on the total number of particles in our system. And you can see that if we add particles, if n is larger, we'll have a larger internal energy. And so the internal energy goes up, increases, as the number of particles in our system, and therefore it is an extensive property. We've also seen that the average square velocity is related to the temperature. And indeed, we've often talked about the temperature as being a measure of the average kinetic energy, or the average speed of molecules in our system. If we rearrange this equation, we can see that the temperature is related to the average square velocity of our particles. When a property, a macroscopic property like temperature, is related to the average of a microscopic property, like the velocity of a single particle, we say that that macroscopic property is intensive. Again, you'll have encountered the definition of intensive in freshman chemistry as meaning that the property does not depend on the number of particles in my system. Because my macroscopic property temperature is related to an average of the microscopic property being the velocity of each particle, the average will not change if I add more particles to my system. Therefore, temperature does not depend on the number of particles in my system and is an intensive variable.